Hello class, welcome to lesson 3.1. This unit, unit 3, focuses on transformations. And the first transformation that we'll look at is reflection. So the question that we want to address, how are the properties of reflection used to transform a figure? So we want to be able to draw and describe the reflection of a figure across what we call a line of reflection. And so the vocab of this unit includes the image, pre-image, reflection, rigid motion, and a transformation. And so we're going to start with transformations because that's the topic of the unit. So a transformation is a function that maps a given figure, which we call the pre-image, to the resulting figure, which we call the image. And so a transformation just takes the original figure, the image, the pre-image, and then makes a new resulting image from it. So for example, let's say we have this pre-image which kind of looks like an arrowhead. And let's say we wanted to induce a transformation, induce a rotation. So we want to rotate this arrowhead. And so if we rotate it and we do use the transformation, then we get this new image. Okay, so we have the pre-image, which is the original arrowhead image. And then we did a transformation, we rotated it, and so now it's just a rotated version of that arrowhead, and that's known as the image. So this is the pre-image, and it's mapped onto the image. And this is what we call a function, taking the original and making a new product out of it. So a rigid motion is a transformation that preserves the angle length and the angle measure. So in the previous example with rotation, notice that the arrowhead did not change. It only rotated. And so these side lengths and the angle lengths have remained the same. So let's look at another example of a rigid motion. A translation. So we have the same arrowhead in pre-image, and we're going to transform it by this transformation. So this is notice that this transformation is a translation. So what I mean by a translation is you take the pre-image and you slide it in a given direction. In this case, I slid it to the right and I slid it up, and that's my original pre-image now becomes the image now that I translated it. But notice that the image has the same angle measures, the same angle relationships, and the same side lengths. So nothing else has changed in this image. And so this is referred to as a rigid motion. So a translation as well as a rotation are examples of rigid motions. So let's look at another example of rigid motion, the reflection, the main purpose of this lesson. So a reflection is a transformation that reflects each point in the pre-image across what we call a line of reflection. Now this line of reflection, you can think of it as a mirror. It's kind of like on the other side in the mirror, you have each point in the mirror on the other side of the mirror gets reflected on the other side. So a reflection has these properties. If a point is on the line, the mirror line or the line of reflection, then the point and its image are at the same point, meaning that there is no reflection going on. But if the point is outside of the line, then it gets reflected. And so line M becomes the perpendicular bisector of some kind of line from B to B prime. So we'll show you what this means. So again, those bullet points are up on the top, and we have a figure given below. So we have a triangle ABC, and notice that point A on the triangle is on the line of reflection. We want to reflect this triangle across this line, line M. Think of line M as the mirror. And so for point A, because it's on the mirror, it stays on the mirror and does not change. And so A prime, reflected point, the primes indicate that you're transforming the coordinates. And this is why it's called a transformation. And so the new point, which we call A prime, is the transform point, but it doesn't do anything. It's just on the line. Now for B prime, because B it's outside the line, it gets reflected. And so my B prime is on the other side of the mirror because it's reflected. And if we were to draw a line from B to B prime, well, that line will actually cross at a 90-degree angle to the mirror line M. And so notice that it's a 90-degree angle. And the line M actually cuts the line from B to B prime in half, which is known as a bisector. And so in this case, line M is a bisector because it cuts it in half. It cuts it into two pieces. Bi meaning two, sect meaning cut. So therefore, line M acts as a perpendicular bisector where it crosses at a 90-degree angle and it cuts it in half. And so this is what it means to reflect. And notice it's the same distance on both sides of the mirror. And so now if you look at point C on the triangle, well then we can see that it has to reflect on the other side, and it has to be the same distance on both sides. And so therefore we have another perpendicular bisector, and it forms a 90-degree angle. And so that's the new point C prime. And so now the new triangle A prime, B prime, C prime can be drawn. And so notice that it is a perfect reflection across the other side of the mirror, line M. And so this is what it means to reflect. So now let's look at an example. We want to ask ourselves, is each transformation a rigid motion? Remember that a rigid motion is a transformation that maintains the shape and angle relationships and side lengths of the original figure. So the side lengths have to be the same and the angle measures have to be the same. The only thing that changes really is that it's either a rotated version or a translated version or a reflected version of its original self, essentially. So if we look at the pre-image, well, we need to see, well, is this really the same figure? And the answer is yes. If you take this pre-image and you rotate it, you can induce a rotation transformation on this figure. You physically rotate it like I'm doing here, well then you can see it's actually the same figure. And so notice that all the side lengths are the same and all the angles are the same. And so this is actually the same figure. And so this transformation is a rigid motion. Now let's look at the second one, pre-image. So we have the pre-image here. And if I were to take that pre-image and I were to say reflected because or rotated because it looks like it's rotated, then I have something like this. But notice that there's something different going on with this image. It's actually longer and bigger in dimension than the original image. And so even if I rotate this or reflect it or anything like that, it's still not going to be the same thing as the image, and it still will not overlap. And because there's no overlap and because they're not the same length, we can confidently say that this transformation is not a rigid motion. Because if I would have to take this and I would have to stretch it out in order to get the same figure, and I don't want to stretch out. So stretching out and changing the length of the pre-image is not a rigid motion. All right, so let's look at an example 2. We want to reflect the triangle FGH across line L, so the blue line here. And so what we're going to do is, remember the rule was that if point is not on the line, then it needs to be reflected on the other side. And so what we're going to do, we're going to show you is we're going to draw the perpendicular bisector. We're going to draw a line segment that gets bisected by L. Okay, so L serves as the perpendicular bisector here. So quickly showing you how you would do this on a compass with a compass and a straight edge. So if you wanted to draw the perpendicular line segment here, then what I would suggest is to follow this process. Okay, so it's a really easy process. So first off, you put your point on your compass on, let's say, point G. And so now my point on my compass is on point G. And then I can adjust this however way I'd like, but I want to keep the same measurement throughout. So let's say I adjusted the compass so it's this length. Now I'm going to draw an arc across the line L. And actually what I'm going to do, I'm going to extend it a little bit further because I won't be able to draw an arc that cuts through the line. So I want to cut through the line here. Okay, so let's say I adjusted it to this amount, and I'm going to go ahead and cut the line with an arc. You want to make sure that it cuts it at 2 points, just like it does here. And so now what we're going to do is we're going to label the point where it crosses, which is here and here. And so those 2 points where it crossed, now you want to go and take your compass and put one of the points on the compass and one of the points that you created. Keep the same length. You don't want to change the distance of the compass, the setting, and then you're going to draw another arc. So let's go and draw another arc like this, like such. Then take the compass, move it to the other point that you made, and repeat the process. Again, don't change the setting. Okay, so there you go. So now we have our Now we have two arcs that cross each other. And so now we want to connect this point right here, which I'll use a different color here. Like that point right there where those two arcs cross and the point G, let's connect it with a straight edge. So we're going to take this ruler or straight edge and we're going to connect those 2 points together the best we can. I'm going to rotate this a little bit further. That looks pretty good. I'm going to go ahead and draw the line best I can. All right, so there's my line connecting those 2 points. And so now I basically have my line here, and the line that I'm interested in here is between G and this point, which we'll call G prime. So this right here is actually G prime. So right here, and I'll do this in blue now, or just so that you can see the line segment that I'm interested in. This blue part right here is what I'm interested in, and this is my perpendicular line segment. So right here, so notice it forms a right angle, and the distance here to here is the same as the distance from here to here. And so now I essentially reflected G on the other side. So let's go ahead and show you this process. I'm going to clean this up a little bit. And so there you go. That's my line segment that is perpendicular to the line L, the line of reflection. And so now we're going to repeat this process for the other points. So in that case, I'm going to repeat that for H, and I'm going to repeat that for F. And so notice that I reflected on the other side. These distances are the same. So this is the same as this distance. This is the same as this distance. And then finally, this is the same as this distance. And so now I will go ahead and connect those with a triangle. And that's my new transformation, transformed triangle, which we call F prime, G prime, H prime. And that's how you go about reflecting a figure. So now let's talk about specific reflections. In terms of coordinates, a transformation that reflects a point across the x-axis means that the y-coordinates change sign. So if I wanted to specifically transform a figure so that it reflects across the x-axis, in this case my x-axis is here, I want to reflect this around here, well then in that case this is going to be flipped onto the other side, right, like this. And then this point will remain on the line. Remember that if the point is originally on the line of reflection, it'll stay there. And so now this will reflect something like this. It's not a very good line, but you can see what I mean. And notice that the only thing that changes in the coordinate here is the y coordinate. The x coordinate is still +1, but the y coordinate changes to negative. And so you can use this as a general rule. If you reflect about the x-axis, only the y value changes sign. And so that's my new line. Notice that the y value changes sign. This should say 1.67, not 1.66, not 1.67. All right, so then we can say as a general rule that that a reflection about the x-axis of the coordinates xy induces a transformation such that the product coordinate is going to be now the same x value, but then the y values change sign. And so this is the symbol that we use for reflections. So we use a capital R, and then here this tells us where we're reflecting about. Are we reflecting about the x-axis? Are we reflecting about the y-axis, etc.? And then this xy is the original coordinates, and so this is our pre-image, and then our x negative y, this is our image, which is our product. Okay, so now let's say we wanted to reflect about the y-axis. So here we're interested in reflecting about here. And so of course, this is going to reflect on the other side. So it'll look something like this. This is on the line of reflection, and so it'll remain. And so we should get something that looks like that. So if we draw that, we'll then notice that the x values are the only values that change. The y values stay the same. So the x coordinate changes sign if you're reflecting about the y-axis. And so the symbol for this is the reflection about the y-axis of the original coordinate leads to a negative x-coordinate, but the same y-coordinate. So you definitely want to get used to using these transformation symbols, because we're going to be introducing more for the other transformations in other lessons. Okay, so let's look at example 3. So we're using quadrilateral FGHJ to graph the indicated transformation. So here we want to do a reflection about the x-axis of the original coordinate xy. And then for part B, we want to do a reflection about the y-axis of the original coordinate y. All right, so let's look at the reflection about the x-axis. So remember, the rule was that if you're reflecting about the x-axis, the y-coordinates change. And so the y-coordinates here are now going to be x negative y. So that's the transformation. And so if I wanted to transform 2, 4, so if I were to do a transformation of a reflection about the x-axis of the coordinate 2, 4, which is point G here, well then that's going to turn into 2, negative 4, right? If I do a reflection about the x-axis of the coordinate 0, 3, well that's going to turn into 0, negative 3, and so on. So you can see that this is just gonna change the sign of the y. So now let's go ahead and say, well, now G prime, this is G prime right here, has to be 2, negative 4 because this is G. All right, so we'll go ahead and say that G prime is 2, negative 4. 1, 2, 3, 4. Call that G prime. This H is now going to turn into 4, negative 2. So it's going to go down to negative 2. And we'll call that H prime, which is now 4, negative 2. This G prime is 2, negative 4. And then now we're reflecting about the x-axis, remember. So because of that, this is our line of reflection. And so J is not going to change at all, right? J is going to stay at the same point that it is there because it's right on the line of reflection. Remember, the point of reflection is that if it's on the line, then it doesn't change. It doesn't get reflected. So now let's do F. So basically J prime is the same thing as F, or as the same thing as J, I mean. And so F is going to turn into 0, negative 3, and that'll be my F prime. So then if we connect these, connect this figure, we have something that looks like this, this. So something that looks like that. And that's my transformation here. This is a reflection about the x-axis. Okay, so now let's repeat this for the y-axis. So now if we were to show our work here, the reflection of the about the y-axis for the coordinates 2, 4, that's going to transform the x-coordinate and it'll be negative 2, 4. The transformation of the reflection about the y-axis of the coordinate 0, 3 is still going to remain at 0, 3 because it doesn't matter if 0 is negative or positive. 0 is neither negative nor positive, so it's not going to change at all. And if you think about it, since we're reflecting about the y-axis, this is the y-axis here, nothing should change. It should still remain at the same point. And so F prime will still be 0, 3. All right, so now let's look at the reflection about the y-axis of G, which is 2, of H, which is 4, 2. That'll just be negative 4, 2, and you get the idea. And so now H prime be at negative 4, 2. So this is going to be H prime, and I'll use a different color there just to kind of distinguish between those two. All right. So it's H prime. This is now F prime. Prime is 2, negative 4. So this is right here, G prime. J is now going to be positive 2 and 0 because it has to switch the x. And so now we can go ahead and reflect this about the y-axis. Not a very good line there, so let me do that. All right. Notice that this is a reflection about the y-axis. Oops, I had to correct myself there. This is, I went ahead and did 2 -4. I meant to say -2, 4, so I apologize for that. Glad I caught myself there. So this should be 2, it should be -2 and 4 right here. Forgot to switch. This should be my G prime. So I apologize for that. Let's go ahead and fix that. Glad I fixed that right away. Something seemed off about the graph, so I went ahead and checked it. Definitely wasn't looking right before. Okay, so now this should be better, right? It's a reflection. It looks like a mirror image and on this side. And then we're going to reflect that. And then we're going to reflect that, just like that. There you go. So now it's perfect. Now that's a reflected version. That's a true reflected version about the y-axis. It looks like a perfect mirror image. And that is the correct transformation. All right, so now example 4. What reflection maps triangle KLM to its image? So we want KLM transform into K prime, L prime, M prime. And we want to figure out, okay, well, what do I need to do to transform it from the black triangle to the orange triangle? And so looking at these two figures, we can tell it's a reflection, because if you reflect it about some kind of line here, it looks like it would reflect on the other side and flip so that it looks like the triangle. But we got to figure out what specific line, what's the equation of that line that reflects these two. And so that's what we're going to figure out. So first off, what we're going to do is we're going to figure out, well, if these two are really reflections of each other, then that means wherever this line is, these 2 points are the same distance from that line. So if this is 5, well, then this darn well better be 5 as well, because if it's a reflection, it should be the same on both sides, right? And so basically what we got to do is we got to figure out the midpoint. Midpoint is the middle point between these two that cuts this thing in half. And so if we find the midpoint, then we can figure out what this line cuts through. All right, so we need to find the midpoint of this line, essentially. So this is what we covered in chapter 2. So how do we find the midpoint? So let's kind of review how to do that. Remember, the midpoint is the average of the x coordinates. So basically you add them up, divide by 2, and the average of the y coordinates. So you add them up, divide by 2. That's the midpoint formula. And so we want to do this for, let's say, L prime. So let's find the midpoint of L prime. Well, so then in this case, if we wanted to do L prime, then if I were to do the midpoint of that, well, I had to add the x coordinates together. The x coordinates are 1 and 3. Divide that by 2. Then I had to add the y coordinates next. And divide that by 2. So 3 plus 1 divided by 2. All right. And so now I need to add them up, divide by 2. So I got here, this should be 1 plus 3, not 1 plus 4. I apologize for that. 1 plus 3 is 4. So we got 4 divided by 2. We got 4 divided by 2. And so this is going to be 4 divided by 2 is 2. So the midpoint here is 2, 2. So let's go ahead and label that on here. This is my midpoint. We'll call that midpoint 1. We'll call that midpoint 1. And then we're going to find the midpoint of somewhere else on that triangle. So let's find the midpoint between M and M prime. Let's figure out where the middle of that is. Okay, so let's do M2. So let's do the midpoint of M prime. So M2. So we're going to add the x coordinates, -5 and 1. So -5 plus 1 over 2. And now we will do the y coordinates, -5 plus 1 over 2 as well. And so we get -5 plus 1 is -4. We get another -5 plus 1, so another -4. So we get -2, -2. There's my other midpoint. So we're over here. We'll call that midpoint 2. And so now we can tell, well, the line cuts through those two midpoints, and it looks something like that. And that's my line of reflection. Now we need to figure out what is the equation of that line of reflection. How do we figure that out? Well, we need to figure out, well, remember that we need the equation of the line. And the equation of the line is given by y equals mx plus b. So let's go ahead and first off find the slope of that line and then figure out the equation of the line. So the slope of that line, if you recall, is given by rise over run. And so if we were to do the rise over run for these 2 points, well, it looks like it runs 1, 2, 3, 4, and it runs 1, 2, 3, 4. So it's the rise is 4, the run is 4, and so the slope is m, which is equal to 4 divided by 4, which is 1. Okay, so the slope is clearly 1. So now we want to figure out, well, what's the equation of the line? So the equation of the line is y equals mx plus b. The slope we indicated was 1. So we have y equals, well, 1x plus b. And we're going to pick one of the points on that line. So let's go ahead and pick this coordinate right here. So x is now -2. And y is now -2 as well. So let's use those coordinates. And so then we have y equals, we can ignore this 1. It's an invisible 1. It doesn't really do anything. But I'll write it down just so that you can see it. So we have 1 times -2. X is now -2. Plus b, which b is -2 as well. So oh, I'm sorry. Not b. Y is -2. Y is -2, so I need to change that. There you go. So now y and x have been replaced. So we have -2 equals -2 plus b. And so if we add 2 to both sides, well, then we get that b is 0. And so basically this is 0. And so the equation of the line is simply y equals 1x, or x. So this is the equation of the line of reflection. And so the transformation here, and I'll go ahead and finish out the answer. The transformation that we're looking at here for the final answer is a reflection for sure. And the reflection is, remember, you use a capital R for reflection, and we're reflecting about the line y equals x of the original coordinate xy. And that's my transformation right there. And what we're transforming here, and really what I should write here is what we're transforming here is the triangle. We're transforming the triangle KLM. We're reflecting that. And when we reflect that, we get triangle K prime, L prime, M prime. And there is my transformation. You can also write this. So notice what changes in this transformation. So let's look at the pattern. So notice that when we had the coordinate 1, 3, it changed to 3, 1. When we had the coordinate -3, 5, it transformed into the coordinate 5, -3. So notice that the only thing that happened was that the x and the y got changed. And so whenever you reflect about y equals x, the rule for the transformation, I'll write this rule in blue, is that if you're reflecting about y equals x, then what happens is that y and x get changed and they get flipped. And this is my rule for reflecting about y equals x. So this is a rule, and then this is the answer to the problem that they desired. All right, guys, that is it for the lesson. So we went over a reflection transformation, A couple of them actually. We went over the general transformations and their rules. We're going to go in the next few lessons. We're going to talk about the other transformations, translations. We're going to talk about rotations and those other rigid motions. But I hope you took something from this video. And as always, I will see you in the next one.